Here is an image of a massive landfill from nearly 20 years ago, filled with rot, flies, and black sludge, and here is what it looked like in 2013. Look at it. The trees grew so tall and dense that sunlight could barely reach the ground. The trunks became so large that 3 people couldn't wrap their arms around one. The temperature inside is about 5 degrees Celsius cooler than the surrounding area. It even takes people hours to find the 2-meter-tall sign that once warned everyone not to enter this landfill. Biomass increased by 176% in just 16 years, while natural rainforests like the Amazon or the Congo need 50 to 200 years to reach this level. Costa Rica truly did an incredible job improving the environment, but what is their secret? How did this happen? Let's begin today's documentary to find out. Almost everyone in the world thinks of Costa Rica as a green paradise. Even though it makes up just 0.3% of the Earth's land area, the country holds 6% of the planet's biodiversity. But few people know that from 1940 to 1980, the country lost more than 60% of its forests, one of the fastest deforestation rates in Latin America, even surpassing Brazil during the early years of the Amazon crisis. Primary forests were cleared to grow bananas, pineapples, and coffee. Agricultural chemicals flowed into rivers and streams with pesticide levels 15 to 20 times higher than safety limits, and grazing land degraded so badly that native trees could no longer grow. The World Bank once warned, if this trend continues, Costa Rica will lose most of its forest ecosystems within 1 generation. That is why, in 1997, Costa Rica became the first nation to pay people to keep forests through the PEELS mechanism. They even abolished their military in 1948 to redirect resources toward the environment, and today, 98% of the country's electricity comes from renewable energy. But what does this have to do with our story today? I just want you to see that this country truly spent a great deal of money to protect the environment, something many nations around the world are still trying to do today. And while the country was struggling to restore its forests, another crisis was unfolding. Since the 1990s, Costa Rica, though not as famous as Brazil or the United States, had become one of the major orange-producing centers in Central America. More than 35,000 hectares and 6 million orange trees were planted, mainly in the northern region and Guanacaste, the same areas that had once suffered the worst deforestation. But the dramatic part is this. 80 to 90% of these oranges were not sold fresh. They went straight into industrial juicing lines for export. And something almost no consumer knows is that nearly 50% of an orange becomes waste: peel, fiber, seeds, and pulp. This means 1 ton of oranges produces 500 kilograms of waste, creating hundreds of thousands of tons of orange waste every year. This waste decomposes slowly, smells terrible, attracts flies, and carries the risk of spreading citrus diseases. One processing expert once said, "We don't produce orange juice, we produce orange waste. Orange juice is just the byproduct." Factories used to burn it, bury it, or transport it far away, all of which burned money. And as orange juice production increased to meet export demand, the mountains of orange waste grew, pushing disposal costs to staggering levels. At that point, the 2 biggest companies, Del Oro and Tico Fruit, entered a fierce competition. One wanted to cut disposal costs, while the other refused to let its rival gain any advantage. As the mountain of orange waste grew larger each day and disposal costs kept climbing, Del Oro knew it was trapped. Every ton of waste costs an extra $40 to $50 just to get rid of, meaning orange waste alone could swallow more than $2 million a year. A former plant manager told a local newspaper, "We were throwing money at something no one wanted to touch. Imagine this. Every morning, glass of orange juice in the world was part of the growing waste mountain in Costa Rica. And just when the company was desperate for a way out, an idea no one expected emerged. 2 American ecologists, Daniel Jansen and Winnie Hallwalks, who had spent decades researching in the Guanacaste conservation area, were facing the opposite problem: dead land. Dozens of hectares that used to be rainforest had been destroyed by grazing and wildfires, leaving only African Jaragua grass, an invasive species that choked out native trees. The soil was exhausted, young plants couldn't survive, and even livestock no longer returned. Jansen described the area as an ecological graveyard where time has stopped. In 1997, when the orange waste problem had become a true nightmare, a proposal appeared that seemed to benefit both sides. Del Oro would donate a strip of forested land bordering the national park, and in return, they would be allowed to dump their orange peels, free of charge, onto the abandoned, degraded pasture. Dumping waste inside a protected area to help conservation? It sounded almost like a joke. But on paper, the deal was a perfect, emotionless win. The national park expanded its territory without spending a cent, and Del Oro escaped the skyrocketing cost of handling hundreds of thousands of tons of organic waste. No one talked about ecological restoration. The chosen site was an abandoned grazing area at the edge of the reserve. Cracked soil, barren ground, no big trees, no shade from a forest canopy. And then, over 6 months, more than 12,000 tons of orange peels, roughly the weight of 2 Eiffel Towers, were dumped there. Trucks ran day and night, piling bright orange waste layer after layer. From a distance, the area looked like a sea of crushed oranges, thick and steaming under the tropical sun. The agreement came with strict, almost clinical conditions. No pesticides, no chemical residues, limonene oil had to be extracted beforehand, and dumping was allowed only on land so degraded that native trees could no longer take root. It was a formula built from soil, decay, and absolutely no expectations, no optimism, no predictions, no promises of any environmental miracle. In the first weeks after the orange waste site formed, the scene in Guanacaste was truly alarming. The orange peels began to ferment, creating a thick, black sludge 30 to 40 centimeters deep, bubbling and steaming under the hot, humid tropical climate. A sharp, acidic smell spread hundreds of meters away, mixing with the leftover orange oil, to the point where passing park rangers had to wear masks. Flies swarmed in huge numbers, and the Mediterranean fruit fly, a threat to more than 200 fruit crops, became a real concern. An agricultural engineer at the time warned on the radio, if this species spreads from the orange waste site, the damage could exceed $100 million. The media jumped in immediately. Sensational headlines appeared: outbreak inside a national park, orange waste poisoning the forest, environmental disaster expanding. Television programs even described the area as a biological toxic dump. Residents within a 2-kilometer radius began to fear for their crops, their health, and their water sources. Many outraged locals demanded answers. How is this conservation if thousands of tons of waste are being dumped into the forest? And then, just like every story that smells of conflict, Del Oro's competitor saw an opportunity to strike. At that time, Costa Rica's orange juice industry was worth nearly $900 million a year, and any small advantage in the export game could become the deciding blow. So Del Oro being allowed to dump waste for free inside a national park felt like a direct insult to its biggest rival, Tico Fruit. While Del Oro saved millions of dollars in waste management costs, Tico Fruit had to invest more than $5 million into its own waste treatment system. And they understood that if Del Oro reduced its disposal costs, the competitor's juice would be cheaper and more competitive in the US and European markets. That's when the media war began. They hired PR firms and launched a wave of press campaigns on TV, radio, and newspapers. Sensational headlines appeared non-stop. Orange peels may cause cancer. The nation's water supply is being poisoned. Region-wide fruit fly outbreak imminent. The core of the campaign was fear. They warned about the Mediterranean fruit fly, an invasive species that had once caused the United States more than $200 million in damages in the 1980s. They pointed to D-limonene oil in orange peels as a carcinogenic substance, even though at the time there was no research proving this in natural environments. But the media didn't care about science, they cared about ratings. And the public, as always, believed things that weren't true. Public outrage exploded. Small protests appeared. TV shows invited guests to warn about an environmental catastrophe. Immediately after the public believed dumping orange peels was wrong, Tico Fruit filed a lawsuit against Del Oro with the environmental court, accusing the project of contaminating the national park and violating the 1995 conservation law. The pressure reached its breaking point. Finally, the Costa Rican Supreme Court issued a ruling terminating the 20-year contract and ordering the project to stop immediately. The head of the regional environmental agency was dismissed, even though the official documents listed a different reason. Del Oro spent more than $100,000 on lawyers, legal filings, and PR, but everything collapsed. The project was shut down, the land was abandoned. No one measured anything, no one monitored anything. No one cared. After the Supreme Court ruling, Del Oro was almost powerless. The project had to stop immediately. But the mountain of orange waste still existed, and every harvest season produced tens of thousands of tons of new byproducts. Del Oro was forced to pivot. From 1999 to the early 2000s, the company began partnering with compost factories, turning orange peels into commercial compost, requiring thermal and microbial treatments to eliminate pathogens, something they never had to do before. Another portion of the peels was sold to farms as soil amendments, but transport and processing costs made the profit nearly zero. One Del Oro engineer admitted, "What used to be free waste is now a mandatory expense." More importantly, the lawsuit cost Del Oro its competitive advantage. Entering the 2000s, they were forced to scale down production and shift to selling fresh oranges and raw materials to other partners instead of producing all of their own concentrated juice. They didn't go bankrupt, but they clearly had to step back to survive. But the story didn't end there. For 16 years, no reports were submitted, no surveys were conducted. The project files were closed, and the area returned to a forgotten state. So much so that many people who once took part no longer remembered the exact place where the orange peels had been dumped. When the Princeton University research team returned in 2013, they had to use old maps, satellite images, and GPS to correctly locate the piece of land that had once been severely degraded. But what surprised them wasn't the difficulty of finding the spot, it was the fact that they barely recognized the landscape anymore. The area once labeled dead land was now covered by dense vegetation, heavy canopy cover, and the clear structural signs of a functioning ecosystem. Native species that had disappeared for decades had returned. The leaf litter was deep, soil moisture had risen dramatically, and organic matter was so thick that light measuring devices recorded almost no sunlight reaching the ground. The transformation was so extreme that the research team had to cross-check climate data, soil records, and satellite images just to make sure they were standing in the right place. So, what happened? When they started analyzing, the ecologists realized the key wasn't in the tree canopy, it was in the soil. The area that had once been compacted, nutrient-poor, and almost unable to retain water now had loose structure, rich organic matter, and unusually strong microbial activity. NPK levels surged, allowing native plants to recover at rates far beyond typical forest regeneration models. The microbial community created a continuous cycle of decomposition and nutrient restoration, turning the orange peels into an ecological ignition system rather than just fertilizer. As the soil retained more water, the microclimate became cooler and more humid, ideal conditions for young plants to survive the harsh dry season. This change sparked the return of decomposer insects, followed by birds and small animals, unintentionally re-establishing the natural food chain. As a result, seeds were brought in through bird droppings, wind, and animal movement, transforming the area into an invisible seed field. Another surprising discovery: the two invasive grasses, Jaragua and African grass, had completely disappeared in the orange peel zone. It turned out that D-limonene in orange peels had a biological suppressing effect that prevented these species from maintaining their populations. Once the grass layer was eliminated, the wildfire cycle, normally fueled by the dry, flammable grass, also vanished. This meant the orange peels didn't just accelerate forest growth, they also turned off one of the region's biggest ecological threats. More importantly, this forest absorbed carbon at an astonishing rate compared to young forests formed naturally. It became a rare example of negative cost carbon sequestration, an ecosystem restored without spending money, while also avoiding the waste disposal costs that the orange industry would otherwise have had to pay. Of course, these results are exciting, but this method cannot be applied everywhere. The case in Costa Rica succeeded only because it met a series of extremely specific conditions. First, this was a controlled experiment, officially permitted, monitored, and clearly limited, not a spontaneous dumping activity. The orange peel site was chosen far from rivers and streams to avoid water contamination, and it was located on land so degraded that native trees could no longer grow. If the experiment had taken place near a watershed, next to citrus farms, or inside a more sensitive ecosystem, the outcome could have been completely different. Climate conditions also played a decisive role. Costa Rica is near the equator with an average temperature of around 28 degrees Celsius, high humidity, and two distinct seasons, perfect conditions for orange peels to break down quickly, form organic matter, release nutrients, and activate soil microorganisms. If the same amount of orange peels were dumped in a cold temperate region or a semi-arid zone, decomposition would be slower, odors would linger longer, and the risk of disease outbreaks could increase. In addition, the orange peels in this project were carefully processed. Natural oils and acids such as D-limonene were removed to prevent harm to young plants. That oil was later used as a biodegradable cleaner, meaning the company not only reduced waste, but also created an additional source of income. Del Oro also had to prove that its entire orange growing area used no pesticides. Because even a small deviation could turn the peels into a biological toxin instead of a soil-restoring material. Although Costa Rica's orange peel miracle cannot be copied exactly everywhere, the world still has countless ways to deal with the massive amount of orange waste we generate each year. According to the FAO, humanity produces about 15.6 million tons of orange waste. If Costa Rica can turn orange waste into a forest, what is the rest of the world doing with this mountain of organic byproducts? In Brazil, which produces more than 1/3 of the world's orange juice and therefore generates more than 6 million tons of orange peels every year, scientists from the University of São Paulo have developed a technology that uses high-intensity microwaves at low temperatures to extract bio-oil from orange peels. This oil, rich in D-limonene, can be burned as a substitute for fossil fuels or firewood. One comparison has shocked many people. If just 20% of Brazil's orange waste were converted into fuel, the pressure on the Amazon, where trees are cut for charcoal production, could decrease significantly. Professor Carol Lynn once said, "Orange waste can replace part of the wood supply, which means we're protecting forests with something that used to be thrown away." However, the technology remains controversial because it requires energy to operate, a small paradox in the effort to green our fuel sources. Meanwhile, in Italy, the approach looks even more futuristic. Designer Carlo Ratti and the energy company Eni introduced a nearly 3-meter-tall machine called Feel the Peel, where users can watch an orange being juiced and its peel dried, ground, mixed with PLA, and then 3D printed into a cup right before their eyes. This closed-loop system turns the simple act of drinking orange juice into a zero-waste material cycle. After drinking, the cup can be recycled or composted. Not far away is Spain, one of the world's top 5 orange producers. The Valencia region accounts for around 60% of the country's output, and Andalusia has increased production by 70% in just a few decades. Here, huge amounts of orange byproducts were once buried or burned, causing pollution and releasing greenhouse gases. But Spanish researchers found a completely different path, turning orange peels into bioplastic bottles through an enzyme process that breaks them down into monomers, which can then be restructured into polymers for molding. One environmental specialist put it in a way that sounds like a slogan from the future: "Organic waste is the petroleum of the 21st century." And then we return to Italy, where the startup Krill Design created the Omi lamp made from the extract of just 2 Sicilian oranges. The product has a light orange cookie scent, a surface reminiscent of orange skin, an integrated dimmer and LED bulb, and can even be composted at the end of its life. The project raised more than $40,000 on Kickstarter, proving that orange waste carries not only physical value, but also emotional and aesthetic value. But perhaps the boldest step comes from Japan, where researchers at the University of Tokyo turned orange peels, onion skins, cabbage leaves, banana peels, and other food scraps into construction material. The results were unbelievable. Most samples reached or exceeded the bending strength of traditional concrete, with cabbage leaf material being 3 times stronger than regular concrete. If a single orange can become a forest, a fuel source, a cup, a lamp, or even concrete, then the world is proving a truth that is both simple and revolutionary. Orange waste is not a problem. It is a misunderstood resource. Back in Costa Rica, do you remember when we talked about how the country once cleared forests to grow bananas, pineapples, and coffee? That means this story doesn't stop at oranges. Costa Rica has one of the highest densities of coffee farms in Central America, and according to its Ministry of Agriculture, every ton of processed coffee can produce up to 2 tons of pulp, husks, and byproducts. These byproducts were once considered an environmental burden, causing water eutrophication, killing fish, and creating truly abandoned patches of land. Then in 2021, researchers published an experiment that shocked the ecological community, covering deforested land with coffee pulp. The starting point looked very familiar: hillsides once covered by rainforest, later converted into farmland, and eventually abandoned once the soil was exhausted. Just like the orange peel site, this place was overtaken by invasive African grass, a plant that prevents native trees from growing and drastically increases wildfire risk. The researchers divided the land into 2 zones, one left untouched and one covered with 50 centimeters of coffee pulp, roughly the height of a preschool child. And then they waited. After only 2 years, the area covered with coffee pulp had 80% canopy cover, with many trees reaching 4.5 meters, almost as tall as the warning sign at the orange waste site that the Princeton team once spent hours searching for. Meanwhile, the control area had only 20% canopy cover. One scientist remarked, "We expected improvement, but no one thought it would be this fast." This is something natural rainforests need decades, sometimes centuries, to achieve. The mechanism is simple. The coffee pulp creates a thick blanket that suffocates and cooks the invasive grass, causing it to die and decompose into organic matter. Once this grass layer disappears, native trees have a chance to sprout. The soil becomes more nutrient-rich and retains water better. Insects arrive, then birds. Then seeds carried by wind and bird droppings fall into place. The bleak landscape transforms into an ecological feast, and in just 24 months, what was once dead land became a nursery for natural forest growth. Do you see the pattern? Oranges restore forests, coffee restores forests. And this leads to a bigger, more dramatic question. If agricultural byproducts can reverse ecological degradation, what would happen if we applied this at a national, even global scale? And don't forget, Costa Rica also has banana peels, pineapple pulp, sugarcane bagasse, cacao shells, rice straw, all massive byproducts. In Nicaragua, farmers used cacao shells to restore acidified soil. In Colombia, banana residue was mixed with soil to help native plants grow again. In Brazil, sugarcane bagasse is used to regenerate cropland after harvest. Are we witnessing a new ecological principle, one where what we call waste becomes the starting point of life? If these byproducts can revive forests in Costa Rica, then what would happen if the world applied this on a larger scale? More than 1/3 of the planet's agricultural land has already been degraded, and 1.3 billion tons of organic waste are thrown away every year, enough to rewrite the ecological map of the Earth. But the real question belongs to you. Are we throwing away waste, or are we throwing away a chance to save the planet? Leave a comment below. Do you believe in the miracle of waste, or is this just a rare exception? And don't forget to subscribe, because the next story will take you to sugarcane, bagasse, cacao shells, and even more unbelievable experiments.